All right, hi guys. So we're going to complete the notes on completing the square. So this is part 2, where I'm just going to go into a little bit more depth. I'm going to explain a little bit clearer on how to complete the square. So let's look at another example. So I want you to write this down. So we're going to have x squared plus 6x minus 7 equals 0. Okay, remember we're talking about a parabola. We're going to have two solutions. We're talking about a quadratic, so it's going to have two solutions. So remember, our first step is that we need to remove our constant. So our constant is here, and it says -7. So remember, we do the opposite. So we're going to add 7 to both sides. Okay, so we cancel our constant, and we're left with x squared plus 6x. And we're going to leave a space here. And then we're going to put an equal sign here, and we're going to add over here. And so we get 0 plus 7 equals 7, right? Now, our goal is that we want to put something, we're going to add something right here. And we're going to also add the same thing over here. Okay, that's why I left this space here. So remember, the next thing that you're going to do is you're going to look at your term. You're going to look at the term with the x term. And you're going to look right here, and you're going to look at the coefficient before the x. So in this case, it's 6. And remember, we're going to divide it by 2. And then we're going to square this whole thing. Okay, so let's simplify. 6 divided by 2 is 3. And let's square it. 3 squared equals 9, right? So our last term here, our constant is going to be 9. So we're going to put a 9 here. The same thing we put here, we're going to put over here. Easy. Okay, now let's simplify. So we're going to say x squared plus 6x plus 9 equals 7 plus 9 is 16, correct? Now, remember, the next part is that we want to get it in this form where we have a parenthesis that's squared equals our 16 over here. So we want to get it to, we want to put our x here because we need x squared. So we're going to put x, right? And remember, the next step is you're going to look at that middle term, which is the same thing we looked at before, which is our 6. And we're going to still divide it by 2. And we're going to get 3. We're not going to square it this time. We're just taking the middle term, dividing it by 2, and that equals 3. And it's plus 3, right? So we have x plus 3 squared equals 16. I want us to take a break for a second here, and I want to explain x plus 3 squared. So over here, I just want to prove that this is correct. So we know x plus 3 squared is x plus 3 times x plus 3. So I just want to explain what this means. So let's FOIL this. First term, we have x squared. Our O, which is our opposite, we have plus 3x. Our middle term, our inner, is 3x. And our last is 3 times 3, which is 9. You guys know how to do that. That's why I'm going quickly. Right? Now we have x squared plus 6x plus 9. Isn't that what we started with over here? So this is correct. So when we put x plus 3 squared, that's the same thing as we're doing right here, right? I'm just showing you that. Now, we want to solve for x in two solutions, right? So in order to solve for x, we need to take the square root of both sides. Now, this is the point I want to explain here. See, this is a radical. We have x plus 3 squared, right? So I want us to think about that for a second. I want us to come over here and I want to explain this. So if you have under the radical, remember this is squared. So we have x plus 3 times x plus 3, right? Because that's squared, right? Remember when we're doing a radical, so like, let me just venture off for a second. Let's just say we had the square root of 3 times the square root of 3. That becomes the square root of 9, which equals 3, right? And remember our radical rule. So I'm going to post a lesson on radicals again, just to review this. But remember, when you are when you're multiplying by a square root, if the number is the same under the radical, it just becomes that number. Example, the square root of 6 times the square root of 6 just becomes 6, right? Because, well, it became the square root of 36, which just equaled 6. So the rule is that if you have two of the same numbers under the radical, it just becomes the number. So let's think about this one. Well, we have x plus 3, that whole term, times x plus 3. Well, wouldn't that just become x plus 3? The same rule applies here. That's why we're squaring, or that's why we're taking the square root of both sides. And we're left with just x plus 3. So basically whatever is under the radical just comes out. So it becomes x plus 3 equals, now remember, this is the square root of 16. Well, we know that the square root of 16 is 4, right? So remember, the square root of 16 equals 4, but it doesn't just equal 4. It could equal, the square root of 16 can equal plus or minus 4. Let's talk about that for a second. Because if you had the square root of 16, you could say positive 4 times positive 4, and we know that that's just 4, right? Or you could take, and well, technically you don't want to have a negative under the radical, but think about it like this. Negative 4 times negative 4, doesn't that also equal 16? So the square root of 16 can be plus or minus 4, correct? So remember, these are two solutions right here because we have a plus and a minus because we're solving for a quadratic. So let's take that. Let's separate our answer. So we're going to say x plus 3 equals positive 4, right? That's one solution. And then we're going to take x plus 3 equals negative 4. Now we're just going to solve for x. Remember, let's go back up here, remove the constant on both sides, right? Now we have x equals positive 1, correct? All right, now let's go over here. We're going to remove the constant, right? And we get x equals negative 7. And there's your answer. So those are our two solutions, 1 and negative 7. Easy, right? I hope that made a little bit more sense. I will go and try another one in just a minute. I will come back on with another video. Bye.